At the core of the universe's structure lies a principle that governs everything: vibrations. These vibrations, while often perceived as abstract concepts in spiritual or philosophical contexts, have real measurable implications in the realm of science. From quantum mechanics to general relativity, vibrations serve as the foundation of the universe's fabric. The geometric grid we previously described isn't a static, unchanging framework. It's dynamic, constantly shifting and resonating. The movement of these vibrations affects the very nature of space-time itself. It influences the behavior of matter, energy, and consciousness. And these vibrations are not random. They follow patterns that are deeply tied to the grid structure and can be described mathematically. The first scientific implication of vibrations comes from quantum mechanics. At the quantum level, particles like electrons and photons don't behave purely as particles. They also exhibit wave-like properties. This wave-particle duality is central to understanding how the universe functions at its most fundamental level. In the context of our model, these waves are the vibrations of the grid. Just as sound waves vibrate through a medium, the grid vibrates, influencing the particles that make up the universe. These vibrations are not random, but are instead intricately connected to the underlying geometry of the grid. Each vibration corresponds to a specific frequency that governs the properties of matter, such as mass, charge, and spin. The interaction between these vibrations and the geometric grid gives rise to everything we experience in the physical universe: the behavior of subatomic particles, the formation of atoms, the creation of galaxies. All of these are the result of the resonating vibrations propagating through the grid, shaping and defining reality. The next step in understanding the scientific implications of vibrations is through the lens of general relativity. According to Einstein's theory, space-time is not a fixed backdrop against which events occur. Instead, it's a dynamic, flexible fabric that can bend and stretch in response to mass and energy. In our model, space-time is not just a passive fabric. It's an active vibrating medium. The geometric grid described earlier serves as the underlying structure of space-time, and its vibrations give rise to the curvature of space-time that we observe in the form of gravitational fields. These fields are the result of the vibrational patterns within the grid, where different frequencies of vibration correspond to different gravitational strengths. When massive objects like stars and black holes interact with this fabric, they create ripples, gravitational waves that propagate across the universe. These waves are the direct consequence of the vibrations within the geometric grid, and they carry information about the masses and energies that created them. On a more human scale, the vibrations of the grid influence our own sense of free will and agency. While the grid is a deterministic system in one sense, the way we navigate through it is not predetermined. Our choices are not the result of a random, chaotic process, but are influenced by the vibrational frequencies we interact with. In this sense, free will is the ability to choose which vibrational pathways we follow, affecting the direction of our own personal reality. The science of vibrations then doesn't just apply to the grand structures of the universe, it also permeates the smallest aspects of our lives. The interactions between our consciousness and the grid influence the paths we take, both in the physical world and within the vast network of possibilities that make up the multiverse. The mechanics of vibrations reveal a universe that is far more interconnected and dynamic than we ever imagined. From the quantum level to the cosmic scale, the vibrations of the geometric grid shape every aspect of reality. They determine the behavior of particles, the structure of space-time, the formation of galaxies, and even the course of human choices. In the framework we've outlined, vibrations are the driving force behind the entire cosmos. Understanding how these vibrations work, how they shape and create, is essential to unlocking a deeper understanding of the universe, and ultimately the nature of consciousness itself.